Hello students, welcome to this lecture 1 Arithmetic Progression. So in this lecture we'll start arithmetic progression chapters. Okay, so in this lecture first we'll introduce arithmetic progression and then we'll discuss about arithmetic progression. Okay, so let's get started. So here let's look for some patterns which occur in our daily to daily life. Some such examples are: first one, Rina applied for a job and got selected. She has been offered a job with a starting monthly salary of rupees 8,000 with an annual increment of rupees 500 in her salary. Okay, and her salary in rupees for the first, second, third, and years will be respectively 8,000, 8,500, 9,000, 9,500, and Okay, so her starting salary is rupees 8,000 and annual increment is rupees 500. Okay, so in each year 500 will increase. So here in first year our salary is 8,000. In second year her salary is 8,500, and in third year her salary will 9,000 and So here you can look some patterns. This okay, yeah, here this term basically second term getting by adding 500 with 8,000. Okay, and third term 9,000 actually get from second term plus 500. Okay, so here you can see a pattern. Now we will discuss next example. So here the length of the rungs of a ladder decrease uniformly by 2 centimeter from bottom to top. See figure 5.1. This is figure 5.1. Okay, so here you can see the bottom rung is 45 centimeter in length. Okay, so this is 45 centimeter length, and the lengths in centimeter of the first, second, third, and 8 rungs from the bottom to the top are respectively 45, 43, 41, 39, 37, 35, 33, and 31. Okay, so basically here the length of the rungs of a ladder decrease uniformly by 2 centimeter. Okay, from top to top, from bottom to top, and the length of the bottom rungs is 45 centimeter, and the length of the second from the bottom, second rungs of the bottom is 43 centimeter. Then for third one 41 centimeter, for fourth one 39 centimeter. Okay, so you can see here a pattern. Okay, so here basically it decrease by 2 centimeter. So here this term 43, this term basically from is obtained from first term minus 2. Okay, and third term is obtained from second term minus 2. So here we get the succeeding terms. By succeeding terms is obtained from preceding terms by adding some fixed number or subtracting some fixed number. Okay, so let us see third one. So in a savings scheme, the amount becomes 5 by 4 times of itself after every 3 years. Okay, and maturity amount in rupees of an investment of 8,000 after 3, 6, 9, and 12 years will be respectively 10,000, 10,000, 12,500, 15,625, 1,900, 531.25. Okay, so After 3 years, the maturity amount of an investment rupees 8,000 will be 10,000. After 6 years, the maturity amount of an investment of 8,000 rupees will be 12,500. Okay, and so on. So here you also see some patterns. Okay, so we will discuss about these examples in details in our arithmetic progression topics. Okay. Now fourth one, here the number of unit squares in square with side 1, 2, 3 and dot 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 units. So this is our figure 5.2. So if you see the figure 5.2, that you see the number of unit square in the squares with side 1, 2, 3 dot 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 units are respectively. So they are 1 square, 2 square, 3 square, 4 square and dot 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 dot. Okay. So the number of unit square in the squares with side 1, 2, 3 dot 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 units are 1 square, 2 square, 3 square and dot dot dot. Okay. Now let us see example number 5. So here Sakila puts 100 rupees into her daughter's money box when she was 1 year old. Okay, and increase the amount by 50 rupees every year. The amounts of money in rupees in the box on the first, second, third, fourth, and dot dot dot, but they were 100, 150, 200, 250, and dot 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 respectively. Okay, so Sakila puts 100 rupees into her daughter's money box when she was 1 year. Okay, when she was 2 years, then Sakila puts 150 rupees into her daughter's money box. When Sakila's daughter was 3 years old, then Sakila puts 200 rupees into her daughter's money box. Okay, and dot 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 respectively. So the amounts of money in the box on the first, second, third, fourth, and dot dot dot, but they were 100, 150, 200, 250, and dot 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 respectively. Okay. Now, in the examples above, we observe some patterns. Okay, and in some we find that the succeeding terms are obtained by adding a fixed number. Okay, and in other words, by multiplying with a fixed number. In other, we find that they are squares of the consecutive numbers and so on. So in the previous examples, there we observe some patterns. Okay, and we find that the succeeding terms are obtained by adding or subtracting a fixed number. Okay, so now in this chapter we shall discuss these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms. Okay, so here in this chapter we'll discuss about this pattern in which succeeding terms are obtained by adding a fixed number to the preceding terms. Okay, so we shall also see how to find their unit terms and sum of inconsecutive terms and use this knowledge in solving some daily life problems. Okay, so our motive of this lecture or our motive of this chapter basically will discuss about arithmetic progression where succeeding terms are obtained by adding a fixed number. Okay, and we also shall see how to find their nth terms and sum of the n consecutive terms. Okay, and use this knowledge, we will solve some real life problems. So here we consider the following list of numbers like 1, 2, 3, 4, dot dot dot. Okay, so here we consider this list of numbers. Can you observe any patterns among these numbers? So here you can see here second terms is obtained by adding 1 with the first terms. Okay, and third term, that is obtained by adding a positive numbers 1 with the second terms. Okay, so here the difference between two consecutive integers is always 1. Okay, so second we have 100, then 70, then 40, then 10, then dot dot dot. So here you can observe that here we added minus 30 with the preceding term and we get the succeeding terms. Okay, so here you can see 70, that basically is obtained by adding minus 30 with 100. Okay, and the third term 40 is obtained by adding minus 30 with second term 70. Okay, and dot dot dot. So here you observe some pattern, and in third one here we have minus 3, minus 2, minus 1, 0, dot dot dot. Okay, so here basically we the succeeding in this list of numbers, the succeeding terms are obtained by adding plus 1 with its preceding terms. Okay, so here you can see minus 2 is obtained by adding plus 1 with the preceding term minus 3. Okay, and minus 1, this is obtained by adding plus 1 with the preceding term minus 2. Okay, and the term 0, here 0 is obtained by adding plus 1 with the preceding term minus 1. And in fourth one, here we have the list of numbers 3, 3, 3, 3, dot dot dot. Okay, so here the whole terms, each terms of this list of numbers are equal. Okay, so here you can find the difference of two consecutive numbers. Okay, that is actually 0. And in fifth one we have minus 1.0, minus 1.5, minus 2.0, minus 2.5, and dot dot dot. Okay, so here you can see that the second terms and third terms, fourth terms, these terms, actually the succeeding terms are obtained by adding minus 0.5 with its succeeding terms. Okay, so each of the numbers in the list is called a term. So what is term? Each numbers in the list of numbers is called a term. And given a term, can you write the next term in each of the list of above? Okay, if so, how will you write it? So here first question is, given a term, can you write the next term in each of the list of above? Okay, and second question is, if so, how will you write it? And the third question, perhaps, and the second question this is, and perhaps by following a pattern or rule, let us observe and write the rule. So we basically find the next term in each of the list by using some patterns or rule, and here basically we'll discuss about these patterns. Okay, so in first one, here the pattern is what? Each term is one more than the term preceding it. Okay, that means the succeeding terms are obtained by adding plus 1 with its preceding terms. Okay, and in second one, each term is 30 less than the term preceding it. Okay, since 170, then 40, then 10, comma dot dot dot. Okay, so here each term is basically 30 less than preceding term. Okay, preceding term. So in third one, each term is obtained by adding 1 to the term preceding it. Okay, and in fourth, all the terms in the list are 3. Okay, so each term is obtained by adding or subtracting 0 to the term preceding it. And in fifth, each term is obtained by adding minus 0.5 to the term preceding it. Okay, so here we adding minus 0.5, or that is subtracting 0.5 from the term preceding it. Okay, so now in all the lists above, we see that successive terms are obtained by adding a fixed number to the preceding terms. Such list of numbers is said to form an arithmetic progression. Okay, so when in a list of numbers, the successive terms are obtained by adding a fixed number to the preceding terms, and such list of numbers is basically said to form an arithmetic progression. Okay, so an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay, so except the first term, in arithmetic progression, there the successive term, that means each term is obtained by adding a fixed number to the preceding terms. Okay, now here this fixed number is called the common difference of the arithmetic progression. Okay, so we discussed in our previous slide, in arithmetic progression, each term basically is obtained by adding a fixed number. Okay, except the first term, and this fixed number is basically called common difference, okay, of the arithmetic progression. So remember that it can be positive, negative, or 0. Okay, so common difference of the AP can be positive, can be negative, can be 0. Okay, so now let us denote the first term of APs by A1 and second term by A2 and nth term by AN and the common difference by D. Then the arithmetic progression becomes A1, A2, A3, A4, AN. Okay, so A1 is first term of the arithmetic progression, A2 is the second term of the arithmetic progression, and A3 is third term of the arithmetic progression, and AN is the nth term of the arithmetic progression. Okay, and the arithmetic progression becomes A1, A2, A3, A4, AN, and the difference, the common difference. Okay, so for the common difference, that is denoted by D. So A2 minus A1, this is equal to A3 minus A2, this is equal to A4 minus A3, and is equal to AN minus 1. And this is actually the common difference of the AP. So common difference of the AP is basically the difference of two consecutive terms. Okay, so the difference between two consecutive terms is called common difference of the AP, and it is denoted by D. Okay, now So we'll discuss now some examples of AP. Okay, so here some more examples of AP are: first one, the heights in centimeter of some students of a school standing in a queue in the morning assembly are 147, 148, 149, comma, dot 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 157. Okay. In second one, here about minimum temperatures. So the minimum temperatures in degree Celsius recorded for a week in the month of January in a city arranged in ascending order are minus 3.1, minus 3.0, minus 2.9, minus 2.8, minus 2.7, minus 2.6, minus 2.5, and dot. Okay, so the minimum temperatures recorded for a week in the month of January in a city arranging in ascending order are this. Okay, now in third one, the balance money in rupees after paying 5 of the total loan, rupees 1000 every month, is 950, 900, 850, 800, and dot 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 50. And in fourth one, in the cash prizes in rupees given by a school to the toppers of classes 1 to 12 are respectively 200, 250, 300, 350, and dot 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 750. Okay, and in E we have given this example: the total savings in rupees after every month for 10 months when rupees 50 are saved each month are 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. Okay, so you can see that a, a plus d, a plus 2d, a plus 3d dot 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 represents an arithmetic progression. Okay, where a is the first term and d is common difference, and this is called the general form of an AP. Okay, so if we ask you the what is the general form of an AP? Okay, so then if we have a first term A and the common difference D, then you can easily write the general form of an AP. That is basically A, a plus D, a plus 2D, a plus 3D, a plus 4D, dot dot dot. Okay. Now note that in examples A to E that we have seen in our previous slide, so in examples A to E, there are only a finite number of terms. Such an AP, such an arithmetic progression is called a finite arithmetic progression. And also note it down that each of these arithmetic progressions has a last term. Okay, so each of these arithmetic progression APs has a last term, and APs in examples 1 to 5 in this section are not the APs, are not the finite APs. Okay, and so they are called infinite arithmetic progression, and such arithmetic progression do not have a last term. So it must be noted down. If AP has finite number of terms, then this AP is called finite AP, finite arithmetic progression. And for finite arithmetic progression, has a least term. Okay, so note each of the arithmetic progressions has a least term. But if the term of the APs are not finite, that means if we have such an AP which are infinite arithmetic progression, okay, that case we can note it down that the arithmetic progressions do not have a last term. Okay. Now, to know about an arithmetic progression, what is the minimum information that you need? Okay. So here for knowing about an arithmetic progression, what is the minimum information that you need? So is it enough to know the first term? First question is, what is the minimum information that you need? Okay. And second question, is it enough to know the first terms only? Okay. And third question, or is it enough to know only the common difference T? Okay. So you will find that you will need to know both the first term and the common difference T. Okay. So to know about an arithmetic progression, the minimum information that you need, you will need to know about first term of AP and the common difference D. For instance, if the first term of an AP A is 6 and the common difference D is 3, then what will be the list of terms of AP? So here first term is 6 and the common difference 3, and we know the general form of an AP that we have discussed in our previous slide. Okay, so if you remember the general form of an AP, so that case we list some numbers like A, comma A plus D, comma A plus 2D, comma A plus 3D, comma A plus 4D, and dot dot dot. Okay, so here the first term A is 6 and the common difference D is equal to 3. Okay, so the first term for this AP will be 6 and second term of this AP will be 6 plus 3, that is equal to 9. Okay, and the third term of this AP will be 2A plus 2D, that is equal to 6 plus 2 times 3, that is equal to 6 plus 6, that is equal to 12. Okay, and the fourth term of this AP, that is A plus 3D, that is equal to 6 plus 3 times 3, that is equal to 6 plus 9, that is equal to 15. Okay, so like this you can find all the terms of this AP. Okay, now if A is 6, that is if first term of an AP is 6 and the common difference D is minus 3, then what will be the AP? Okay, in that case, how can we write the AP? We know the general form of an AP, that is A, comma A plus D, comma A plus 2D, comma A plus 3D, comma A plus 4D, comma dot dot dot. Okay, so here we have given the value of A is equal to 6 and the value of D is equal to minus 3. Okay, so the AP is 6, comma 3, comma 0, comma minus 3, comma dot dot dot. Okay, similarly, when A is minus 7 and D is equal to minus 2, that case the AP is minus 7, comma minus 9, comma minus 11, comma minus 13, comma dot dot dot. Okay, and when A is 1.0 and D is 0.1, that case the AP is 1.0, comma 1.1, comma 1.2, comma 1.3, comma 1.4, comma 1.5, comma dot dot dot. Okay, and when the first term A is equal to 0 and the common difference D is equal to 1 of 1 by 2, that case the AP is 0, comma 1 of 1 by 2, comma 3, comma 4 of 1 by 2, comma 6, comma dot dot dot. Okay, and when the first term A is 2 and the common difference D is 0, then the AP is 2, comma 2, comma 2, comma 2 dot dot dot. Okay, so today's lecture is about this. Okay, so in this lecture basically we introduce arithmetic progression, and we discuss about definition of arithmetic progression, and there we see some examples of arithmetic progression, and we we also discuss what is the minimum information that we need for making an arithmetic progressions. Okay, so I stop here this lecture. Thank you very much to all of you.